Here we have a word problem in front of us. And the first thing that I tell everybody when they hit word problems of this size on the AP Calc test is just take a breath. It looks intimidating at first, but it probably isn't going to be as bad as all those words make you feel like it is. So let's take a look through here and see what they've given us and where we need to go. So the first thing they tell us in this word problem is the number of people who have entered a pool is given by this function here. And then the number of people who have left that same pool is given by this function here, g of t. Then the additional info they give us is not about those original functions, but about their derivatives. So I know the derivative of my f equation, and I know the derivative of my g equation. And then they tell us a little interval here. And then the final thing they're looking for is they want to know the number of people in the pool at a maximum. When I see a word like max or min, that really tells me that what I'm probably looking at is a first derivative test. And so I just start running through that first derivative test process. The first thing I need to know when I'm doing that process is what is the equation I'm trying to take the derivative of? Well, this one wants us to take the derivative of, or find the maximum of, the number of people in the pool. Well, I don't have that equation specifically. I need to create that for myself. So I'm going to call this equation, I'll call it P for the number of people in the pool. So P of t, the number of people in the pool, is going to come from taking the number of people who have entered the pool, so my f of t equation, and then subtracting off of that the number of people who have left the pool. So that would be my g of t equation. That's the formula that I'm trying to find the max of. And then I just run my brain through a first derivative process. Step one of the first derivative would be to find the first derivative of that equation. So this is just going to be a notation game. P prime of t is going to represent the derivative of my number of people in the pool. And then the derivative over here is just going to be, again, a notation game. The derivative of f of t would be f prime of t. And then I'm going to subtract off of that the derivative of g, which would be g prime of t. Step two on a first derivative test is you always need to then find the critical value. Finding critical values, you just take your derivative and you set it equal to 0. Then the third step on this is we'd have to then, that would find our critical values, but then we would want to see if that critical value is a max or a min. So at some level you're doing what I normally refer to as a number line game. You'd have a critical value, maybe another critical value, and you need to see if it's positive or negative on either side. If we're looking for a max, what we would want to see is we would want to see a positive derivative going into that critical value, and then a negative derivative coming out of that critical value. So doing that shows us that we would have a max going on in that situation, which is what we want specifically for this problem. So now I need to find those critical values. Well, that was coming from step 2. So I go back up here to step 2, and I've sort of said, okay, that's what I need to run through, and what can I do with the actual values they gave us? Well, I have a formula for my derivative of f, and I have a formula for my derivative of g. So I really can just set that up. I can set up that formula. So 0 has to equal 230 times 1.03 to the t, minus, and then always in parentheses, when you're subtracting a piece, you always want to subtract the full equation. So make sure you put that in parentheses and then go grab that g prime equation. So 240 plus 130 sine of pi, they couldn't have made this any longer, could they, of t minus 5, all of that is over 6. So you'd be looking at that and being like, man, how am I ever going to find when that equation equals 0? That's a monster algebra problem. Well, the great news for us is we actually don't have to solve that by hand because we're on a calculator required section, which means we can use the calculator to find where that's occurring. So what I would do is I would start by taking this first equation here and putting that into y1 on my calculator. I'm going to put my second equation, the 0, into y2 on my calculator. Then I will graph it, and wherever those two graphs run into each other, that intersect is where I have critical value. So I would graph it, and then I would go through a second calc, and then I would choose that number 5 option, intersect. And that's going to get me my critical values. And then hopefully from there, I can decide what step 3 is going to look like, where my positive and negative derivatives are going to be, and get my final answer. So I open up my calculator, go to my y equals in the top left corner, and I start typing in what they gave me. So this would be 230 times 1.03. Whenever you're graphing, no matter what they call that variable, you're always going to call it x when you're graphing. And then I want to subtract, and again, don't forget you're subtracting that whole second piece, so make sure you start with a parentheses. Then we put in our 240 plus 130 times the sine of, and when you need a fraction, it's easier than putting in the parentheses everywhere. You can have the calculator split this into a fraction for us. If we just hit that alpha button on the left there, and then the x button right next to it, that splits it into a fraction for us and just makes it a heck of a lot easier to continue to enter this in. So then I'm going to do pi times, and again, don't put a t, put an x minus 5. Close that, go down to the bottom, put your 6 in, close that, and then close the whole thing. So then that's our y1 right there. It's massive, but doable because it's all on the calculator. And then we set that equal to 0. Before we graph this, remember that this equation, these systems only work, or that only count for a window from 1 to 10 there. So before I graph, I would go ahead and hit my window button. And I would set my x min to 1 and my x max to 10 because that is all I care about. I want to know the max in that little window of time. I hit graph. There's my first curve, and then my second curve comes in. And what I can see is I've got 2 intersects happening here, one in the middle and one on the outside. And where those graphs intersect each other, those are my critical values. So I'm going to go find those critical values and put them on my number line. So I hit second calc. I choose the number 5 option, intersect. It's going to ask me a series of 3 questions. The first 2 I could really care less about. It's saying, is that the first curve? Yep, that's the first curve. Go ahead and hit enter. It'll switch automatically to the second curve and say, is that the second curve? Yep, that's the second curve. Go ahead and hit enter. And then the guess is the one that really matters. The first time through, I'm just going to guess right where I'm at because I'm basically on top of it. And I hit enter. It says the word intersection at the bottom of the screen, and I see the x value that goes with it. So that is my first critical value, and I mark that sort of on my own little number line here. So I'd say, okay, there's my number line, and my first critical value is happening at 5.44, and we'll round it to 3 decimals because that's what they always do on the AP test. So 5.448. That's my critical value, and then I've got another critical value. I find it again by hitting second, calc, number 5 intersect, first curve hit enter, second curve hit enter, and then this time when it asks me to guess, I'm just going to scroll all the way over here to the right so I'm closer to that intersect, and I hit enter a third and final time, and I get out the intersection is happening at 9.939. So then the other critical value is happening at 9.939. Now what I need to do is I need to come back and find my positives and negatives. I need to be able to check which one of these is actually giving me a max and which one might be giving me a min. So when I read this, I go back and I say, okay, I am at my critical value right here. And I say to the left of that, what is my derivative value? Remember, we are graphing the derivative. Well, to the left of it, that's where my graph is up here in the positive derivative space. So to the left of that original critical value, this is in the positive and therefore increasing. To the right of that critical value, my graph drops down into the negative here. This is the negative part of the derivative value, so then that would be negative in between those two. So then that tells me that I would put a negative right here, and that would be decreasing coming out of there. And then, looking at it again, I would come back over here and I would say, okay, well, just beyond this other critical value, it heads back up into the positive just for a moment. And so then in that space, I would be looking at a positive and increasing. So now I can read off where my maxes and mins are occurring. I'm looking specifically for the maximum. So I look at mine and I say, oh, this goes positive into negative. That tells me that at that critical value right there, I have a max. So the max of this original equation of how many people are in the pool would be happening at this value here, 5.448. So going back through this real quick, what you would do is first you got to come up with an actual equation for what they're trying to find the max and the min of. That was our number of people in the pool. Once you know what that equation is, remember that from there you're running through a first derivative test. So set up your steps on a first derivative test and see what that would look like. And then once you know what that process would look like, you go in and work with the values you were given. And luckily on this one, we also get to work with the calculator to find our final answer. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.